Okay, so we had some fun with factoring. That was great. Now let's use it. Welcome to 5.5. I'm going to tell you right now, if you can factor, this next section is going to be super easy. Let's get into it. All right, here we go. Solving polynomials by factoring. So there's not a lot of new stuff in this section. We're just using the slightly more complicated factoring that we learned the last lesson, and then we're just gonna solve problems. So step one, you're gonna move all the terms to one side of the equation so that the equation equals 0. Okay, that's nothing new. We've done that before. So we're gonna move all numbers, variables to one side of the equation. We're gonna factor the polynomial completely. And then we've done this before too. We're just gonna set each factor equal to 0, and then we'll solve. But this time we know how to solve for a lot of different ways, a lot of different methods. We can solve using the square roots, the quadratic formula, and then we can simplify all irrational and complex solutions. So we're doing the same thing, but at a much higher level at this point. So let's try some examples out. All right, looking at number one, we always start easy, right? So step one for factoring, we always look at what they have in common. By the way, step one for solving is move everything over to one side, set it equal to 0. This is already equal to 0, so we're good to go. Anyway, so we're gonna pull an x out whenever we factor. So now we're gonna have x squared plus 1 equals 0. And now we can solve. We can set this term equal to 0 and then this term equal to 0. And so what that's going to look like is we're going to have x equals 0. Okay, well, that's already done. Got it. So now we're also going to have x squared plus 1 equals 0. So we now have the mechanics to solve this. We're going to subtract 1 from both sides. Normally, I would go, oh no, we're about to square root both sides. We're going to have a negative sign under there. But again, we know how to deal with that, right? So we're going to have x equals plus or minus I square root of 1, which is actually just 1. So it's just going to be plus or minus I. So now we've got three solutions. So if you're going to be like technically correct, we would write x equals the set of 0, I, and then negative I. I put them in out of order, but whatever. I'm never going to gig you for that. This is perfectly acceptable for me. So let's do another one. Okay, number 2 is not set up for us to factor yet, so that's fine. We're just going to move this term over to that side. And I choose that side because A, I like my leading coefficient to be positive. It just makes my life easier. And B, there's more terms over there. So again, let's just try to do less math. So we're going to subtract 3x squared from both sides. That should be a squared. So then we're going to have 4x cubed minus, what is that? 10x squared equals 0. Okay, so now we can factor. So we can pull an x squared out. Then we're going to have 4x. Oh, we can pull a 2. Yeah, let's pull a 2 out while we're at it. Because why not? It's going to make our lives easier. So we're going to pull a 2x squared. So then we're going to have 2x left. And then a 5. All that equals 0. And again, just like before, you're going to set this thing equal to 0 and this thing equal to 0. So we're going to have 2x squared equals 0. In this case, x would equal 0. Normally, we would square root plus or minus 0, but there is no such thing as a negative 0, so it's all the same number. So just x equals 0. So then our other one over here is going to be 2x minus 5 equals 0. Move the 5 over. 2x equals positive 5. x equals 5 over 2. And that's it. We're done. Here is where we start having fun, right? So we look at this, and hopefully you recognize that this is a version of a squared. Yes, it's 4, but you could just do x squared times x squared. This is also a squared, so 8 times 8 is 64. So hopefully you recognize that this is a difference of squares. So again, if you're not good at perfect squares, if you see a squared and a minus sign with nothing else, there's a high likelihood that you should check for difference of squares. Anyway, it is difference of squares, so we're going to factor it that way. Using our pattern, and you can use your sheet for this, but I know that, so like my A is going to be equal to x squared, my B is going to be equal to 8. So then I'm going to have x squared plus 8 times x squared minus 8 equals 0. You should note that there's an x squared and a minus sign, so I'm thinking difference of squares. So we're going to look at this. If I go through my perfect squares, I've got 2 times 2 is 4, 3 times 3 is 9. It's already above 8. 8's not a perfect square, so it's not difference of squares. I like to go through that process, though, just so that you start recognizing, I should double check that to see if it's difference of squares. It's not. Okay, so we're going to set this side, the left side equal to 0, and the right side equal to 0. So our left side is going to be x squared plus 8 equals 0. Subtract 8 from both sides, x squared equals negative 8. Square root both sides, we're going to have plus or minus I square root of 8. We need to simplify that, by the way. Don't leave it like that. So then we're going to have plus or minus I. A 4 can come out of there, so that's going to be 2 square root of 2. So yes, I skipped a couple of steps right here, but we hit how to simplify these pretty hard. So if you still need work with that, let me know, and we'll get some more practice going. Okay, the other side, we got x squared minus 8 equals 0, plus 8 to both sides. So x squared equals positive 8, x equals square root of 8. So we're going to say plus or minus, and we already know what the square root of 8 is. So I'm just going to go straight into 2 square root of 2. So our final answer is going to be x equals the set of plus or minus I square root of 2. No, just kidding. Plus or minus I 2 square root of 2, comma, plus or minus 2 square root of 2. And remember, there are actually 4 values that are listed here. This means that there are 2 separate values. But there you go. Looking at number 4, I see a 5, I see an x, I see another 5 that I can pull out, and I see an x. Step 1 in factoring, always pull out as much as you can, the greatest common factor. So we're going to pull a 5x out. So now we're going to have x to the 4th minus whatever 80 divided by 5 is, 16, equals 0. So if hopefully you're recognizing this, we've got an x, a potentially squared number here. Yes, again, it's 4, but we're just going to say x squared is x to the 4th, minus that triggered my difference of square alarm. Looking at this, 16 is a perfect square. So we are going to factor this using difference of squares. So we've got 5x on the outside. We're going to have x squared, 4? Yeah. Minus 4, x squared plus 4 equals 0. We're done factoring, right? No. Again, we've got an x squared and a minus sign. So we should check for a difference of squares. 4 is a perfect square. So we're going to factor that one more time using difference of squares. We can't factor this one at all, so that one's just going to stay the way it is. But here we go. So we've got our 5x. It's going to be x minus 2, x plus 2, and then our x squared plus 4 just comes on down. And there we go. So now we're going to set each individual factor equal to 0. So we're going to have 5x equals 0, x equals 0. We're going to have x minus 2 equals 0, x equals 2. We're going to have x plus 2 equals 0, x equals negative 2. And then we're going to have x squared plus 4 equals 0. 4 goes over, x squared equals negative 4. Square root both sides, x equals plus or minus. The square root of 4 is 2, so it's going to be I2. Or 2I, whatever. And that's going to be our answers. So like our final answer would be x equals the set. Let's go smallest to biggest. We'll start with our imaginary numbers. 2I plus or minus 2, and then 0. And that's our answer. I see an x cubed. So I'm not as good with cubes, but I do remember that if I have a perfect cube plus a perfect cube, that's a thing that I should remember. And if I remember correctly, 125 is one of those numbers. I'm going to double check. I'm going to use my calculator. I'm going to go to math, scroll down to number 4, cube root 125. It's going to give me 5. So we've got a sum of cubes, and so that means that like our A is going to be x, our B is going to be 5, and we're going to use, I'm using this cheat sheet, we're going to use our sum of cubes pattern to factor this. So that means we're going to have x plus 5, x squared minus 5x plus 25. So as we're looking at this probably is factorable. So we should probably try to look into that. Let's see here. 25, two things added up. 25 divided by 2, not a thing, 3, 4, so 5 and 5. That's not going to get us anywhere. That might not be factorable. So if it's not factorable, it's not factorable. I guess we have to use the quadratic formula. I hate doing the quadratic formula. So we'll start with the easy one. Here we've got x equals, so we're going to equal 0. X is going to equal negative 5, so that's one of our answers. The other one, here we go, quadratic formula. And that's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to have to plug all of that in. So here we go. Negative 5 plus or minus square root of negative 5 squared minus 4 times a times c all over 2a. Okay, so now we've got 5 plus or minus square root 25 minus 4 times 25 is 100 all over 2. So that's going to equal 25 minus 100 is negative 75. 5 plus or minus square root of negative 75 over 2. What can come out of 75? 75 by So I can divide 75 into 25 times 3. So we can pull that 25 out. When we pull that 25 out, we're going to have 5 plus or minus, and we got to pull the negative sign out too. 5i square root of 3 left over all over 2 and equals x. And I'm honestly going to leave it like that. You can split this up into two different things, but it's still going to be the same number. You can't simplify it anymore. So x equals -5 and 5 plus or minus 5i square root of 3 over 2. I love the quadratic formula. Number 6, I'm going to factor it. It does still use the quadratic formula. I'm going to let you guys do that. I'm not going to waste your time here looking at it over and over again. So it is not equal to 0 yet, so we got to move that 4 over. So we're going to have 8x to the 5th, so you're minus 4x squared plus x squared equals 0. So we've got an x squared. We can factor that out. So now we've got 8, 5, 4, 3, x cubed plus 1 equals 0. So if you have a cubed plus another perfect cube, we have a rule for that. So we can keep going. So we're going to keep that x squared on the outside. And I'm going to look at my rule right here. Oh, wait. 8. 2 times 2 is 4. Yeah, okay. 8's a perfect square too. So my a is 2x. My b is 1. Running that down so I don't get confused. So we're going to have 2x plus 1. And I'm looking at my rule to figure this out. A squared is going to be 4x squared minus a times b, which is 2x, plus b squared, which is 1. And at this point, so you can solve this part, you can solve this part. This part you will need to use the quadratic formula for. Plug it in and see if you get our answer of x equals 0 from there. X equals -1/2 from there. And then x equals 1 plus or minus I square root of 3 all over 4 from our quadratic formula there. Try that one out yourself and see how it goes. So number 7, we've got a cubed minus a, I think that's a perfect cube. Let's check. There you are. What is it? 2, 16, what was that, 4? No, 6. Okay. So that means that my a is going to be x and my b is going to be 6. So looking at this thing again, remember this is difference of cubes now. So I'm going to have x minus 6, and then we will have x squared plus a times b, which is 6x, plus b squared, which is 36. So I'm looking at this guy right there, trying to figure out if we can factor it. Looks like it's not easily factored. So you can use either completing the square or the quadratic formula. You know, I thought about it and I hate completing the square less than I hate the quadratic formula, so that's what I'm going to do. So, so we're going to have x squared plus 6x equals negative 36. So I put it back over on the other side. The completing the square thing is 6 divided by 2 squared. So that's 9. So we're going to add 9 to both sides. So now we've got x squared plus 6x plus 9 equals negative 27. So that we can factor into x plus 3 squared equals negative 27. And then from there we can square root both sides. So we get x plus 3 equals plus or minus I square root of 27, which is the same as x plus 3 equals plus or minus, we're going to pull a 9 out of that 27, so that we're going to have 3i square root of 3 left over. This 3 goes the other side, so we get x equals negative 3 plus or minus 3i square root of 3. And that is our answer for that one. Don't forget, we got to set this one equal to 0. And then we get x equals 6. So there you go. At this point, I'm just going to highlight my answers and go. So to save some time a little bit, I'm just going to go straight to 9 and go down the left side of the page. So when I'm looking at 9, that it's going to get kind of confusing, right? So we've got all these x4s, x squareds. So I've mentioned before, sometimes it might be easier to just swap those variables out. So if I say y equals x squared, I can change this into y squared plus y minus 42 equals 0. And I just got to remember to put the x squareds back in later on. So that kind of makes a little bit more sense. So if I look at 42, we're going to see if this is factorable. Divided by 2, I need them to subtract together to get to 1. So not 2, 42 divided by 7, it's 6. So we're going to have y plus 7, y minus 6 equals 0. So we're going to put those x squareds back in. X squared plus 7, x squared minus 6. You don't necessarily have to use the y's, but sometimes it's easier to visualize these things like that. So then that equals 0, that equals 0. Just notice this is a square and a minus sign. So my brain went to this. Is that a perfect square? The answer is no. So then I don't need to factor that at all. Okay, so then we're going to have x squared plus 7 equals 0. X squared equals negative 7. X equals plus or minus I square root of 7. Nothing comes out of 7, so we're good on that one. So then if we go to the other one, we're going to have x squared minus 6 equals 0. X squared equals 6. X equals plus or minus square root of 6. Nothing comes out of that one, so we're done. Looking at number 11, I immediately see that there's an x in each one of those, so I'm going to pull that out before I even start looking at the rest of the problem. Plus 16 equals 0. Handwriting is terrible, but whatever. Okay, so is that factorable? Looking at 16 divided by 2 is 8. 16 divided by 4 is 4. Added together will give me 8. So I'm going to make sure I bring my x down. So x minus 4, x minus 4 is going to equal 0. And so then when we solve for all of this, we're going to have x equals 0. x equals 4, x equals 4. So all we would have to write down is x equals the set of 0 and 4. Now remember, 4 would technically have a multiplicity of 2, right? But in this case, it is just the one answer. So just trying to make some connections there. So number 13, we got to make it equal 0 first. So the 16 is going to go over there. So we're going to have 3x to the 4th minus 2x squared minus 16 equals 0. I can't even tell you if that's factorable or not because we got this 3 here. So we're going to do the slip and slide. So now we're going to have x to the 4 minus 2x squared minus 3 times 16, 48. Now remember, there's an x4 and an x squared, but if you want to just sub y's in for it so you can see it better, that's fine. But you don't really have to, just as long as you can recognize that, you know, it's still factorable. Equals 0. Okay, so 42, we got to subtract together to get to 8, to get to 2. I'm sorry, 48, and then to get to 2. So 48 divided by, 48 divided by 8? There it is, okay. I started at like 9, I thought 9, 7, and okay. Anyway, got to 8. 8 and 6, so 8 minus 6 is 2, so we're good to go with that one. So it's going to be x squared. The bigger number should be negative minus 8. X squared plus 6 equals 0. I see a squared. I see a minus sign. I'm thinking difference of squares. No. So that is 8 is not a perfect square, so we're good to go on that one. So if we have x squared minus 8 equals 0, x squared equals 8, x equals plus or minus square root of 8. Then we've got x squared plus 6 equals 0, x squared equals negative 6, x equals plus or minus I square root of 6. Thinking if I can reduce that one reminded me that I can probably reduce that one, so we should probably do that. So then we've got x equals plus or minus 2. So I pulled a 4 out. Square root of 4 is 2. And then we're going to have a 2 left over. And then we just have x equals plus or minus I square root of 6. Hey, finally we get to some good ones now. So remember, this has 4 terms. So how do we factor something that has 4 terms? We're going to use grouping. So if we just group these two together and these two together, we'll see how and where that takes us. So our first two, well, here you go. We'll do a different color here. So our first two on the left, we can pull an x squared out. So we're going to pull an x squared. So then we have x plus 2 left over. And then on the right, we're going to pull a 5 out. So then we're going to have an x plus 2 equals 0. Oh, look, they're the same. So now we're going to have an x plus 2 on the outside. We're factoring that out. We're going to have x squared plus 5 left over. And then from here, we're doing the exact same thing that we've been doing. X plus 2 equals 0. X equals negative 2. X squared plus 5 equals 0. X equals negative 5. I'm sorry, x squared. Square root of both sides, we get x equals plus or minus I square root of 5, because there's that negative sign right there. So there you go. Just because it's fun, I'll do number 16 as well. And then we'll give the answers for the rest of them. So again, it's 4 terms we're going to use by grouping. So we're going to group these two together. We're going to group these two together. So we'll start with our first one. We can pull an x squared out. X squared 2 x minus 3. Notice that there's a negative sign right there that we don't particularly want to deal with. So we're going to have to pull that negative sign out. And that 32 needs to go down to 2. So that means we're going to have to pull a 16 out as well. So then 48 divided by 16 is 3. So we're going to have 2x minus 3 equals 0. Oh, look, they're the same. We were going for that. So we got 2x minus 3, x squared minus 16 equals 0. Oh, look, it's a squared minus a perfect square. So yeah, that's right. We're going to do some difference of squares now. So don't lose our first term. It's still there. But now we're going to have x minus 4, right? X plus 4 equals 0. So now our answers. So when this one equals 0, we're going to have 3 over 2 equals x. And then we're going to have x equals 4, x equals negative 4. So our final answer is going to be x equals plus or minus 4 and 3 over 2. So there you go. Like I said, not terrible if you know how to factor. So I'm going to go back through and show you the rest of the answers. That doesn't mean that you can just write down the answers. Please show your work. Most of the stuff you cannot do in your head. I highly doubt that you can. So please show your work. Okay, like I said, I was going to give you the answers, at least for the other ones. I still want you to try them yourself, but the answers are there. You can check your work. So as we go down, when you see something complicated like this for number 8, you're probably going to have to use like the quadratic formula or completing the squares or something like that. Just to get there. Number 10, the answer doesn't look too bad. Plus or minus I, plus or minus 1. Number 12, we've got 0, plus or minus 2 square root of 2, plus or minus I square root of 3. When I look at that, I would factor out a 2x squared, see where it takes me. Number 14, we've got plus or minus I square root of 3, plus or minus square root of 15 over 5. And again, you're just going to have to move these over here. And it looks like you've got an x4 and an x squared. So either sub a variable in or just keep in your mind that you can factor them as if they were squareds, but then just don't lose the x squareds. And that's how you're going to get that one done. So try them out. See how it goes, and I'm sure we'll do more examples in class.